So next, we are going to have a person that I admire very much, because he has the privilege to sail around the world on a boat. And he is, I think, this experience has made him get tired of sailing, and maybe he wants some robots to be able to sail on the ocean and resolve the problem in the ocean on behalf of the human beings. That's here we have Cesar, who is going to share with us how he resolved problems like the oil spoil, resolve the problems like ocean surveillances with very, very affordable cost, material, and processes. It's not for some very high-tech, very state-funded projects. It's for everybody now. You can interact more interestingly with ocean. So here we have Cesar.
Hey, thanks everybody. So, I think many people here, you will hear that we are all born makers, but we are all liking all these shiny, shiny devices, either because we make them or because we consume them. And so, the life or the end of life of this product is much less glamorous than the initial lust or passion that we have for these objects, because most of the stuff that we're going to be making, even here at the Maker Faire, is going to end up like this. Most of the electronics devices, that's how they end their life, and that's terrible. And so if you look at those materials, actually a lot of it is plastic. So I'd like to speak first about plastic pollution, and in particular plastic pollution in the ocean. So this is a picture I have taken in the island of Hilo in Hawaii, and this beach is called Camilo Beach. Most of the beach is made of plastic. Actually, there's no sand on the beach. All the beach is made of plastic on several meters deep. And if you find some birds in the area, most of them will be probably dead, and they'll be filled up as well with plastic. They think that the plastic bits is food, and they eat it until they die. Turns out that we also eat other birds, so we eat also fish. So the plastic that we produce doesn't go in the environment, so it comes back to us. Today, we produce every year 300 million tons of plastic every year. And it's estimated that about 1% of plastic is actually ending up in the ocean. 80% of the ocean have plastic in them. So the way that we measure plastic pollution in the ocean is that we take those nets, and every few miles, then we will pick up the nets, and we will measure them, each piece of plastic, with a microscope. And then we will plot and make a map out of all these plastic bits. But that's very long, expensive, and potentially dangerous when you're navigating on a boat. I teach to kids what I would say, some people call that citizen science. And with the kids from the age 5 to age 13, we built this bench. It's like a mini makerspace for a primary school. And what we did is that we collected some plastic pieces from the beach, and then we grinded them and cleaned it up. And then we hacked some webcams and changed some filters, put some specific LEDs, and we also hacked some toy boats. And we tried this toy boat with a webcam and the Raspberry Pi inside of it, and we captured some videos of plastic going through the robot. Then we run OpenCV software, and we try to identify the type of plastic by looking at the size of the plastic bits, the opacity, and trying to guess roughly the weight of each piece of plastic. The idea is to develop a real-time sensor for plastic bits, so we can differentiate where we find the plastics, location, what kind of plastic it is, and what is the quantity, and we do this with really young kids. We documented this on Instructable. I guess you all know that website, best website in the universe. And so the project manager is 8 years old, so he's leading the project. Another derivative pollution from our consumption is radioactive waste. So maybe you know, a couple of years ago, in 2011, there was a huge earthquake in Japan, 20 in the sea. 20,000 people died immediately because of the wave, and still today, you have radioactive materials that is leaking from the nuclear power plant in Fukushima every day. And so this is the simulation of the radioactive particles traveling through the ocean. So right now, all the Pacific Ocean has traces of Fukushima cesium-134 and 137. And so these are the isotopes that I've been tracking with a team of French scientists and Safecast. So with a team, with Safecast and the small team that we built ourselves, we went very close to the nuclear power plant. We went 1.5 kilometers away from the nuclear power plant. That's the closest a civilian team has been to the nuclear power plant. What we've done is that we've collected fine sediments from the seabed. We're collecting this fine dust that is coming from the nuclear power plant, and we're putting it into plastic bags. As you can see, we're not wearing any protection. The perimeter, the reason is because actually the governments say it is safe. They assume it is safe, therefore they don't really encourage people to put the protection. And if you put protection there, either you look like an idiot or maybe you're trying to make a fuss about a known problem. The Japanese government in general is trying to say there's no problem, therefore you shouldn't wear protection, but actually don't really know what's going on there. So we worked with the local fishermen, and they were able to collect even more sediment than we could. This is the nuclear power plant just behind. So we analyzed these sediments, so we split the sediments and we send it to different labs. And these are the machines, germanium, that measures radioactivity, and we made a map of the coastal radioactivity. So we have some data about the deep ocean, we have a lot of data from the land, but very little from the coastal area, which is where most fish are being captured. Without this data that we've collected with the open source technology, it's very dangerous to even think about going fishing out there. You might be catching fish, but you don't want your children to eat it, right? So you really want to know what is the state of the environment in this area, because you could get sick. Oh, let's go. Okay, another type of pollution I like to talk about is oil pollution. Before going to Fukushima, I was actually involved with the BP oil spill. So in 2010, so just 1 year before, there was the largest environmental catastrophe in the North American continent. So there was the biggest catastrophe in America. There was the BP oil spill. And basically there was oil almost all over the southern coast of the US. So that's where the red star is, where the oil spill started. This is the heavily affected area. And in yellow is all the area that's actually affected. And what you could see on the ground was this. You could see oil all over the place. That was terrible. And you had more than 700 of these boats that operated for 3 months, non-stop, to try to collect the oil, but they could only collect 3% of the oil that was leaking. The cleanup involved human beings like this, just collecting by hand liters and liters of oil. So I started to work on an alternative solution of a boat that would be wind-powered, and the goal was to drag this long sponge. You see this white sponge, that's the same. So the idea is to have a small boat, a robot, that will be capturing this oil. So the first thing I did is to hack some radio-controlled toy. This one you can see has a front rudder. Most of the regular boats have a rudder at the back, but this one has a rudder at the front. So that was the first test. And I play with this one, and it works better than a normal boat, so I tried to put 2 rudders, one at the back and one at the front. So that was in Korea, South Korea. And we tried this boat, it works not so well, it works okay. But then I come back to New Orleans, where the BP oil spill started, and I built the first shape-shifting sailing robot. So it's a boat that's shape-shifting. That means that the hull bends. So you have no rudder and no centerboard, the whole boat will change shape. And so that's a boat that's very fast. It's very maneuverable. You can really turn in a very agile way. And it's also very good for going up the wind, because you can change the shape of the boat. So you can really control the boat very, very finely. It also works very well in high speed, as well as in low wind speed. So here it's very, very low wind speed. But look at the position of the sail. So we're turning into the wind, and the front sail and the back sail turn almost at different times. So what's happening here is that when you're turning, you're exposing the sail at 2 different angles of the wind. So it means that you are never stuck against the wind. That means that you can pull a lot of payload, you can put a lot of stuff behind it. So it was almost like an evolutionary process. I wasn't inspired by animals at the beginning, I was just doing some mechanical experiments, but it turns out that this is, right now the shape that we have is very similar to the organic shape. And so we wanted to see if this technology could work on a larger scale. So we just hacked some other plastic tubes and bicycle pumps and valves, And with $100, we can make this 3 meters shape-shifting boat that's inflated. Then we worked on Kickstarter, and we fundraised $30,000 US, and we rented a big factory, and we built the same thing, but automated, with a lot of engines inside of it. And basically, it's a rocket with a sail. So it's a sailing robot that doesn't have any passenger, so you're not on the boat, but it allows you to have great speed, great pulling power, and a flexible boat. So you have many new performances. And recently, we start to make them in series. We actually launched last year at the Shenzhen Faire, but it was a soft launch. We just built a few units. This is a more recent test with a modular architecture. So instead of having just one shape-shifting sailing boat, we can actually build boats like a train. So if you make a boat that's modular, you can actually have a completely different architecture. So what a shape-shifting sailing robot brings, a whole new world of physics for sailing. We have new properties in how we can control the boat. We can absorb the impact of waves. We can sail closer to the wind. We can maneuver. We can build the boat like a train, like this. And now we are going from Arduino to an Android platform, because an Android phone usually has a GPS and accelerometer and a bunch of other stuff that are really useful for us. And more recently, I've been working on this prototype. So it's trying to demonstrate the physics of a modular wind power structure. And the point we're trying to make here is the low energy consumption. So this vehicle is 3.5 meters long. And the only thing that I need to control is the angle of the front wheel. And to prove you that this same architecture of machine can use the very little amount of energy, we built double the size of the machine. So this machine is 6.5 meters, so bigger than a car. But the energy it uses is the same as a mobile phone, because the engine is actually just a tiny servo motor. And so what's interesting is that the bigger we make the vehicle, and actually the smaller the energy because we're using, because the vehicle is going faster, so actually we don't need as much force, as much torque on the servo. So it's very interesting, means that we could make a very large transportation system with very low energy. So we are very lucky that we have found somebody who is crazy enough to want to buy from us large boats, but that's the next boat we're going to build. It's going to be for human beings. So we're going to have human beings going inside of our boats and trying to test the limits of how quick we can go and how maneuverable the boat is, and if we can actually really make tight turns, if we can pull a lot of payload, and eventually we're looking at replacing human beings on these boats to carry a lot of different tasks. So all this technology I showed to you, of course, it's open source. So all the hardware is open hardware licensed. The code is GPL3. The documentation is Creative Commons. The only thing that we kept is the trademark. So very similar to Arduino. And maybe other people have talked about it, but open hardware is this magic intersection where we document our work in a quite sometimes similar way as academics will write the documentation, because you want other people to be able to duplicate your experiments. You want them to improve or prove you wrong. And that allows also the industry to help you, because somebody wants to make money out of this or wants to put on a bigger scale. And because you have transparency, the government as well can support your project if you're working in open source, because they can see exactly what you're doing. You are perfectly accountable. And also, if you're working with citizen science, if your work is documented properly, then it allows anybody to come and jump in on your project and help you. So what I showed you today, these 3 experiments and the boat technology, I'm trying to find out how we can make a technology that's actually good for the environment. And if you think really hard about it, it's very hard. Even if you make a solar panel, for example, you make a solar panel and you install it. But just the time for producing a solar panel, you're going to use a lot of energy to collect the minerals to make the solar panels. And then you're going to use a lot of heat to manufacture the solar panels. And then you're going to deliver the solar panels. Say this is when you switch the solar panel on. You start to produce electricity in a way that's more energy efficient than, say, I don't know, oil or gas or coal. And then maybe after you use 5 years, your solar panel, then it has offsetted its own energy bill. And only from there, you start to have a real environmental impact that's actually positive. That's good here. So if you can you think of any technology that you know that actually has almost no red and a lot of green? It's really hard, but this is what we need to think about as makers, is how can we create those technologies so they have an environmental impact that's actually good for the environment. That's super hard. So we are building this new place in Hong Kong just for that.
Including new solutions to social and environmental problems the world is facing. A place with tools, space, workshops, events, and a creative community of fellow makers to share, inspire, and collaborate with you. A place of freedom where you can grow your creative projects, turn your ideas into prototypes, then manufacture them in factories across the border. A place where high-tech and traditional craftsmanship meet and flourish at the heart of the fastest growing region in the world. We're building this place for you here in Hong Kong. At Maker Bay, you can work on wood, metal, 3D printers, laser cutters, CNC mills, composite materials, textiles, and experiment with chemistry, biology, optics, and robotics. Maker Bay is here to support you as you put your imagination to work and create better solutions for our people and our planet. Whether you're a hardware startup developing the next electric car, a student that imagines putting solar-powered computers in the most remote communities around the world, or a hobbyist dreaming of 3D printing a flying machine, Maker Bay is designed for you. Now that you have a place where you can make anything, what will you make?
So of Maker Bay, there is myself, Cesar, and there's also Abby. Can you raise your hand? So we are here from Maker Bay, from Hong Kong, and we are going to open the space Monday. So most of you guys will still be in Hong Kong. So please come and visit us. We are building a large makerspace. It's 6,500 square feet. So we are located is in the center of Hong Kong. That's at the train station Yau Tong. It's 25 minutes from the central station, 25 minutes from Mongkok. And this is the space a couple of months ago. We just got an old factory, and then we called the community and asked them, what do you want? What kind of space do you need to make your ideas come true? And so this is the team, and this is on the Facebook. We exchanged some design ideas. How shall we design this makerspace? What kind of area do you want to have? What kind of machines do you want to have? And this is the floor plan that we have. So at Maker Bay, you will find a big space. You will find a lot of tools, more tools than you can find anywhere in Hong Kong. And of course, a great community. And the way that we're going to help people achieve better environmental and social technology is that we will have discount for people who do open source, social, and environmental technology. We're going to have a Maker in Residency program. So if you have a project that's good for the environment, please come and talk to us. We want to support you. And eventually, we'd like to run an incubator or accelerator for our hardware startups that are for the environment or for social good. So I hope that my presentation convinces you that being a maker is not only about making cool stuff, but it's also thinking about the whole life of your product, how it's going to affect society. So if you think about a mobile phone, at the beginning you have a passion, or you're very obsessed with a new technology and you just want to buy it. But then you discard it. You want to buy the next cool new thing, and what happens to your mobile phone? It goes into the dump. It goes into the ocean. And the problem is that this kind of relationship that's consumerism is not only for object anymore. It's also how many people start to treat each other. But we need to cherish each other the same way we also cherish objects. And if we keep destroying objects on the scale that we all consume, of course it will destroy the environment, which is the supporting system for us to make more stuff. So for the love of making stuff, we're actually destroying our capacity of making stuff. So we are makers and we're responsible. Everything in this room has been made by somebody who is a maker, who invented it, who manufactured it, who delivered it. And we are the makers, as the makers, we are responsible for this transition. Hong Kong was a fishing village. The Delta, the Pearl River Delta was just a fishing area a couple of 100 years ago. It became this incredible economic and industrial place. And now we have to go and become this really creative place, and hopefully reaching this state of wisdom where we are more than just producer and consumers. this is what you find on like an Apple device. It's created in California, invented in California, and manufactured in China. But this needs to change. You guys are smart. You come from everywhere, but many of you here are Chinese. I don't want to see this label anymore. I want to see great technology coming from right here. I want to see great technology coming from here because you have here all the ingredients to make these massive changes. You have the technology, you have access to the ocean, you have the best logistic instrument in the world. You can ship stuff here, you can ship things from here at the cheapest rate. Whatever you can invent here can reach the world in no time. You're in the best place in the world to do this. And I think that you are the best people because you are the makers. So this is the best time, the best place, and you have the best capacity to affect the greatest change. So if you start to think about how you can do some good things for the environment and for social good, then I think you can have a great impact. Thank you very much.